of building sector is really evolving very fast and getting bigger and better with every passing year. But the pressure is also very high because the demand from the market is also increasing very rigorously. Just to set the context, India's building sector is going to overshoot the country's entire carbon budget if not addressed in the right way. Like I mentioned, the expectations from our built environment are continuously evolving. Buildings are now required to play multiple roles in, above and beyond of just being a habitable place for all of us. Even usage of buildings and construction of buildings also leads to a lot of emissions, and quantifying that is going to be the next big story over the years to come. So addressing sustainability imperatives at the facility level. A facility could be a building, a residential building, a commercial building, a factory, a warehouse, a hospital, a college campus, a data center, or any kind of a build structure. Each of these disparate building typologies are now basically supposed to play a role in addressing the environmental sustainability if they are part of any and every organization, or even if they are operating standalone. If we look at the total today's building landscape, buildings account for roughly 40% of the overall emissions. And here is the broad breakdown of a global average, which is coming directly from ASHRAE's positioning document on building decarbonization. Here we can say that residential has still got a role to play, important role to play. Non-residential, although less, it is significantly taking a leap because our needs are increasing as our country, India, is taking a very important role in its development and growth story. So we are left with a very broader landscape where we are struggling with cities that are getting crumbled and very rapidly urbanized, where buildings have got very less space, and we are starting to build vertical cities. And there is a lot of pressure on architects as well, because they are basically supposed to think in all these directions. They have to address climate change. They have to address the electrification in the buildings. The buildings should also generate their own power these days. If somebody is wanting to address net zero goals and all that. Plus, at the same time, there is unprecedented stress from all other human activities that are associated with it. Uh, a major part of this problem, of course, can be solved by managing what we've got already. Now, if we look at the overall building cycle or overall building life cycle, you can see that there are various activities right from the schematic design phase till the operations and maintenance phase. So this slide basically just covers up the entire building life cycle, and you can see there are two dotted boxes that you on the screen. The first one, which covers the design and construction, basically talks about the building materials which are responsible for the embodied carbon or the embodied energy of that building. And beyond that, whatever happens is considered as the operational energy. Now, there are various pathways, established pathways, by which we can really take control of both these types of emissions: the embodied carbon during the building design and construction, as well as the operational carbon during the building operations and maintenance. Now, I'll focus the bit of the next few minutes on the operational energy part of it, because that is ultimately the outcome of what gets planned or what gets decided during the design phase. But then whatever we are doing at the design phase has to really stick around and continue during the entire duration of the lifetime of the project or the building. So keeping one eye on what is manageable, operable, and maintainable is a very important task that today's architects and engineers have got a role to play on. And ultimately, if your sustainability imperatives or your design goals are towards achieving net zero performance in any of the dimensions, energy, water, or even carbon, you have to really navigate through all of these key processes, where you start with designing with certain intentions in the mind, certain goals in the mind, where you have to really go above and beyond your energy codes or the requirements of the rating system. And then there are levels to it. But in all of this, one thing is very certain: whatever the building is going to emit, that needs to be really measured, quantified, and reported in many occasions to the various stakeholders involved in the running, operating, and maintaining the building, as well as to the other stakeholders, like you could have tenants or you could have clients who are really going to ask you. So, and all of that is basically enabled by, the building automation systems, which have got a very critical role to play here. To make this simple, you think of the building automation as a three-level maturity model. Level one is just the basics, and level zero is basically no automation. Level one is just the basics, just the metering and monitoring of where the energy is coming from, how much energy is getting consumed across the building level and the major utilities. This could be a read-only, function by a means of energy meter or a water meter. And this level is something which is mandated by all these green building rating systems that we heard about, be it IGBC or GRIHA or even LEED. All of them are basically asking you to really have the basic metering infrastructure in place. Only and only then you will be able to measure and monitor what is going on in the building. Now, the next level is basically feedback based or with the read write capabilities where the equipment gives a certain feedback, or you get other feedbacks based on the climate conditions or the occupancy profiles. And that is the next level of maturity. And the level 3 is even advanced, where you are basically looking at fault detection and diagnostics, demand response, load optimization, and other things. In the Indian context now, we are basically struggling somewhere between level 0 and level 1. And this needs to really improve. Building's performance depends heavily on whatever you are able to quantify and then leverage it further. Now, this gets even more complicated in multi-tenant buildings. Different tenants often bring in different teams, different systems, different priorities. Unless expectations are set at the very beginning, it is really difficult to align them. At the very least, there should be a level 1 common automation program platform so that the energy and water performance data is captured consistently across all tenants. Now, these are all design decisions. That's why at the design table, one needs to be very clear of what is going to be the outcome of the entire exercise when the building gets into the operations and maintenance phase. So at a minimum, having this level of maturity where you are able to quantify all the emissions belonging to a building's operations is a must-have. And this is also being addressed by the recently released editions of our green building rating systems, as well as the building energy codes. Like ECBC 2024 version talks a lot about this. And the recently, energy auditor for buildings has also come up. And all of this is basically getting evolved in this direction. And eventually, in the due course, we'll get to see that all the buildings are gradually shifting to the level 2 maturity and eventually to the level 3 as well. Now, in addressing all of this, there are definitely certain challenges in the Indian context. I'll just quickly get you there. So the skills gap, we definitely need deeper engineering and architecture expertise. The idea of shifting from designing green buildings to designing green performances is very powerful. But in order to achieve that, these are the challenges that needs to be really thought through. Even housing or even commercial projects, do not really find basic sub-metering for different end users. Without having these data, everything gets a little patchy where, sensors are misreporting and all of that. So I'll not get into the details, but the skills gap needs to be addressed. And beyond that, the lowest first pass, that mindset is really been limiting, our building sector as well, because sometimes even the builders are not sure what is going to happen when the building is built and occupied by a random tenant. But then they end up, undervaluing expertise and long-term savings that could be brought in by means of certain, interventions based on architecture or engineering. Then there is hopeless and neglect. Technicians or engineers really needs a lot of tools and training and a proper handover from the people who have designed and installed all these equipments in the building. So if that gets corrected, then basically everything starts getting streamlined, and the data that gets generated is also more credible. And we are basically in the middle of moving or evolving from working in silos and adopting those integrated design practices. As we follow some of the national as well as international rating systems, in most of our projects. Plus, this is going to be more pronounced in the near future when more and more states basically adopt the energy codes and these kind of requirements in their compliance models. So in a nutshell, the market is evolving, but one thing is certain that all buildings are eventually they become existing buildings, and we need to measure, monitor, and report, and then assume responsibility for what we emit. Once a building is built, it stays kind of forever. You keep on, evolving or changing a few things here and there, but the main skeleton of the building stays there for decades together. When we talk about emissions reporting and greenhouse gas emissions, very soon, the talk of the town is your emissions could be my extended emissions. They're talking about scope three, and hence every entity has got a stake. Everybody has got an important role to play, and the blame shifting cannot really go beyond a certain point of time. And all of this is continuously being addressed by even the international, technical societies and councils like ASHRAE and USGBC. But at the same time, even the government of India, entities like CII, who is running IGBC, all of they have started evolving their rating systems also in order to align in this direction. So it is always going to be a combination of a bit of passive architecture features that are taken care of early design stage, plus high-end engineering features. So these days our buildings are basically highly engineered buildings also. So on that note, I'll be open for any questions that you have. Just a snapshot of this could be our future too very soon if we do not really take the right direction of developing and operating our buildings more responsibly.